Good morning, students. Today we are going to start our chapter Work Energy Power belonging to our subject Science. Students, this is chapter 11 and we shall in the first lecture we shall discuss about the fundamentals of the particular chapter Work, Energy and Power. Our first topic is work. Now, what is work? Think about it. Think your own words, in your own words, that what work is. Before we study work, we need to understand some fundamental primary things which makes the work. Those are force, distance, displacement, etc. Before we study work, we must be familiar with what is force, distance and displacement. I shall teach you from fundamental way. What is force? Notice my words. Force is any push or pull. Understand this. Any push or pull which can change the motion or shape of an object. Again, force is any push or pull. What can it do? It can change either shape or motion of an object. I shall explain it to you with an example. It is a push or pull. I am taking the example of change in shape. Suppose I am having a spring in my hand. There is a spring in between my hands. If I apply some force, or I say if I am pushing it, what will happen? The spring is having a certain length, say 50 centimeters. The spring is having a length of 50 centimeter. If I apply some force from both my hands, then what will happen? It will compress and its length will reduce to anything less than 50. Take 35 centimeter. What have I done? I applied some force, or I say I pushed it and its length got decreased. Clear? So this is one example that if we apply some push, then the shape is changed. Or we can say a sponge, our bike tires. These are some certain examples of change in shape when we apply some push. Another example, the change in motion. Clear? Assume that a kid is riding a bicycle coming towards you. His cycle is moving with a velocity of take 10 meter per second. The kid is riding its bicycle with 10 meter per second of velocity and it's coming towards you. What will happen? You would like to stop him, and what will you do? You will use your hands to push him, and his bike will come to a stagnant position. What will happen? The motion will change. Its velocity will reduce from 10 meter per second to 0 meter per second. You stopped it. You braked it by your hands. This is an example of change in motion. Or take another example. You are riding your bike and the road is completely open and you are riding with a high velocity of 80 meter per second. Suddenly you got into a crowded market. What will happen? You will do something. You will apply force on your brakes, either by your hand, either by your foot. You will apply some brakes. What will happen? Your velocity, which was 80 meter per second in an open market, high velocity, you applied some force. You pushed the lever of the brake. What happened? Your velocity decreased from 80 meter per second to 20 meter per second. Clear? So what is force? Force is basically any push or pull which can alter or which can change either the shape or motion of an object. I said it can, not necessary that it will change. For example, it can, not definitely it will. Suppose I have some muscular power in my body and I am trying to apply some force on this wall. Can I change its motion? Never. my physical, I don't have that much physical strength that by applying force or by applying push I can move this wall. I can change neither the motion of the wall or nor I can change the shape of the wall. Clear? So force can change, but it will not certainty. Clear? So I'm thinking that you are having an idea what a force is. Now we are moving towards distance and displacement. We shall study them together. Clear? Fine. Distance and displacement. Not by definition, we shall study it by example. There are 2 points A and B. Because you are a student, so we shall study it by your example. This is our classroom and this is our bathroom of school. Classroom of school, bathroom of school. There are 2 students who wants to use bathroom in after a certain period. One student is extremely intelligent and he is very interested in studying, and one student is quite mischievous. There are 2 conditions. One student asks permission from me that teacher, I want to go to bathroom. I shall say okay. He will go to bathroom direct. Okay. Another student who is mischievous, and we are giving them name. One is intelligent denoted by I and one is mischievous denoted by M. 2 students, I and M. I went to bathroom in the straight path, same to same. M also went into straight path, but while returning there will be a difference. What will happen? I wants to attend class sincerely. I want to attend class sincerely, and he returned to the class from the bathroom in straight path very rapidly. So he covered a shortest distance from bathroom to the classroom. Clear? From position B to position A. Completely straight path. This is condition number 1. What about the mischievous one boy? What will happen? He will not come to the classroom direct or in shortest path. He will round and round, wandering from one place to then he will return, because he want to pass his time and doesn't want to attend his lecture. Clear? So in simple words, I can say that he came into class covering a long path, a long length. Clear? This is condition 1 and this is condition number 2. Now understand what is distance and what is displacement. The shortest length between 2 points is known as displacement. The shortest length between 2 points. The intelligent boy covered a shortest length, a straight path. A straight path is always the shortest one. Clear? The shortest length is always known as displacement. And what about the condition number 2? Any original length between 2 points B and A is known as distance. I hope it is clear to you. Take another example. Say right now I am taking lecture here and I want to go my home. Clear? Okay. How will I go to my home? It's not possible that my home and this school has a path of completely straight. It doesn't have any straight path, not a single road which goes to straight and straight. If that happens, that is an ideal condition, that will be displacement. But before my home comes, I have to cover long turns, path, lots of something like this. This is distance. Another example, if I want to go from here to Delhi and I have 2 options to go, one by road and one by flight, by air. If I am going from road, definitely roads are not always straight, they have lots of turns. So if I am going from by using the roads, then I am covering distance because it has some turns. And if I am going through flight, flight doesn't take, I can take that as an ideal condition because aeroplanes always move in straight path, not in turning mode. Clear? So while I am moving, while I am using the air mode, then I am covering the displacement between Bikaner to Delhi. I hope that you are clear with distance and displacement. Now we are coming to our main topic. What is work? What is work? Take this. In physics, it is a certain thing, 2 or more than 2 If two or more than two physical quantities combine together, they generate a third effect. If one physical quantity is there, it has a certain effect. Another physical quantity is there, it also generate a certain effect. If I mix them both, they will generate a combined third effect. Clear? So what is work? Our main topic was work. What is work? I will help you. I'll show you it for using formula. The basic formula of work is F into D into cos theta. F into D into cos theta. What just happened here? I told you what force is. I told you what distance and displacements are. If I combine them together, a third effect will generate. What is that effect? Force. F into T. The basic formula of work is F into D into cos theta. Hide cos theta for a second. What are you saying? Work is force into distance or displacement. So you can say, you can think of a definition that what the work is. The definition of work I am explaining you. Notice my words. If we apply some force on an object, it covers some displacement. Again, if we apply some force on an object, it covers some displacement. This is known as work. Clear? If we apply some force on an object, it covers some displacement. Both effects are combined. This is known as work. So what is cos theta doing here? What is its role here? We do not apply force always in straight mode. The force can be on some certain angles, like there is something just at the angle of me and I am pushing it. Take an example. I hope you must have did this in your childhood. This is a surface. Clear? There is a toy car having some wheels. This is a toy car. Clear? A boy is standing here. I'm not that much good in drawing, so understand a boy is there and he is having a rope attached to the toy and pushing it. You can see that boy is not pushing this car in a straight mode. There is certain angle. This is the role of cos theta here, because force can also be applied at certain angle. Another example I am taking you. You must have visited to a village, don't you? Okay. There are some women which pulls some water with the help of a pulley bucket system. You know? They pull out some water with the help of pulley bucket system. What happens there? The force is not applied in the straight mode. The force is in angle. A woman is suppose that there is a pulley and I am the woman who wants to take out the water from the well, and I will push the rope like this. I am not pushing like this. I am pushing the rope like this. So it is inclined. It has some certain angles. So this is the role of cos theta, because force can also be applied at certain angle. Clear? So the basic formula of work is F into D into cos theta. So there are three things which play an important role in work. How much force you are applying, how much distance or displacement is being covered, and at what angle you are applying force. The force can be applied manually or mechanically, any machinery mode. Clear? Okay. Now there are also types of work. There are three types of work. You must be familiar with that. I will explain you their names and their regular examples which we use in our daily life. The work is of three types: positive work, negative work, and zero work. Three types of work: positive, negative, and zero. Think about it, what these are. Do you know any examples of these three types of work? Let me explain you. The positive work is always when work and force both have same direction. If I am applying force in that direction and work is also happening in the same direction, this is positive work. Example, I am having a box here. I will apply force towards this direction. I am applying force in that direction. Okay, the object will also move in that direction. This is positive work. And what is negative? It's just opposite. What? If I am applying force in that direction and the object is moving in backward, in the opposite direction, that is negative work. Think about it. Where does it happen? You must have visited to a railway station, don't you? right? Okay, there is a coolie who with whom we pay and he carry our luggage. What happens? For an example, I am having a big weight of luggage lying there on the platform. What will I do? I will put that weight in on my hand. Clear? What I just did. You know how gravity works. It always apply force in the downward direction. Clear? Okay. When the coolie put on the weight for putting on his head, what happened? Gravity was working downward. Gravity was working downward, and where was the object moving? Upward. Clear? Gravity was forcing the object towards downward, and he put the object towards upward. Both the directions are different. Force is being applied downward, and the object is moving upward, opposite directions. This is negative work. Clear? And what is zero work? I am just giving you a fundamental. We will just study it in details. Clear? In later on classes. What is zero work? It's quite simple. Either the force is zero or the distance is zero. Then the work is positive, because you know simple concept of mathematical. You multiply anything with zero, complete becomes zero. Say force is 1000, but distance is zero. What is 1000 into 0? It's 0. Or say force is not being applied, means force is 0, but distance is being covered. 0 into whatever the distance is, always multiplication becomes 0. So either the force is 0 or the distance is 0, the work will be 0. What are the conditions? One condition we have already discussed. What? I am having extreme, so I am a bodybuilder. I am having lots of power in my muscles. What will I do? I will apply some force on this wall. I am applying lots of newtons of force on this wall, but is this wall moving? No. I do not have strength enough to move this particular wall. So I am applying lots of force, but I cannot move this wall. The distance is 0, the displacement is 0, so the work is always 0. One condition. Another condition, when force is nothing but distance is something, like say a surface is parallel to ground, but there is a inclined path in the midway. Clear? You are moving an object which having wheels here. There is a toy car moving on this surface. You are applying some force and it is moving, it is moving, it is moving. Clear? But when it comes here, on this ground, on this inclined plane, what will happen? Now, do you need to apply any force? Not at all. Gravity works on its own. The object will move without you apply even 0.1 Newton of force. Clear? You do not need to apply any force, but the object is moving. Distance is being covered, but force is nothing but 0. Clear? This is the example when force is nothing but distance is something. Clear? So what is zero work? Either the force or the distance. Any of them or maybe both of them are 0, then the work is 0. So these are three regular life or daily life examples of types of work: positive work, negative work, and zero work. Clear? So this is a brief description about work. We shall study in details. I will provide you notes as well, questions, exercise, lots of things. We shall study each of these topics in details in later on classes. Clear? Okay, thank you.